Hey everyone, in this video we'll be learning how to use cursor to implement type checking. This is not the video on type hinting or type checking in Python. So if you need a refresher or an introduction to that, I'll link a couple of videos in the description and you can go through them and they'll onboard you pretty well into understanding what we'll be discussing in this video. But this video is strictly about adding LLM into our workflow when it comes to implementing type safety. Okay. First of all, why do we even need type hinting or type safety in Python, considering it's a dynamically typed language, and unlike statically typed languages like C or C++ or Java, Rust, etc., it's not necessary for us to implement type safety in Python. Our Python code will work just fine even if we don't care about it. Let's start with an example just to show why it might be useful to have type checks. Again, goes without saying that LLMs are non-deterministic, so even if you have been following along with me so far in this video series and using the same prompts and models that I've been using, it's likely that the code that AI might have generated for you would be different from what I have here. But a lot of these principles are generic, so you will still be able to follow along even if the code output is not same. For instance, it's likely that even your cursor AI response might have already implemented some type hinting or type annotations like I have here in our get AI response function. So you can already see that our client parameter is annotated to have open AI as its type, and our config parameter should have chat config, which is the class which we define to implement our chat model logic. Config parameter should have chat config as its type, and user query should be a string. Let us go to where we have called this get AI response function. Okay, so we are calling that function right here. Just assume that instead of config object here, so if you look at this config argument that we are passing in this function, it is of the type chat config. Okay, so we are instantiating chat config class here, and then we are passing it as an argument to this function. Now, instead of that, for whatever reason, we have a new developer who is not being very careful, and instead of passing config object, they end up passing config string. Now see, even at this point, it's not giving us any warning or error. So far what we have done is we have only hinted at types. We have only implemented type hints or type annotations in our function here, but we have not yet enforced it. It's still not giving any error, even though we have added a string argument where it should have been an object. More precisely, a chat config object. So let's try to run this code in our terminal. Okay, so we'll run uv main.py. Okay, and let's ask this question to LLM, and you can already see we are getting an error that string object has no attribute get messages. This error is because instead of passing config object, we are passing config string in get AI response function. But the problem is that unlike config object, config string will not have get messages method. It's not defined for a string, but it's defined for our chat config object, which is why we're getting this error. But ideally, we like to see this error happen before we execute or run our code. And this is where enforcing type safety comes into picture. Okay, so if we can find a way of getting a warning or an error at this point itself when we are adding this argument to the function, then that will save us a lot of trouble later. And that is one of the use cases of implementing type safety, is that more specific and precise we are in defining our types and enforcing them, better we will be at catching bugs before we even go ahead and run or execute our code. Other use cases might be that the moment we start defining our types when we are writing functions or other areas of our code, we will have to think and be more explicit about the data structures that we are dealing with. So for example, client or parameter in this function will be the OpenAI class that we are importing from OpenAI library. Okay, and our config parameter has to be the chat config class that we have defined that has different methods and attributes dealing with logical implementation of chat model. Okay, and user query obviously is a string, but it always helps to understand the data structure in as much detail as you can when you're writing the code. Type hints or type annotations also serve as a documentation for any human developer that is not yet familiar with the code. So if there is a new developer, they might infer what it's implementing just looking at the parameters and their types. In the post AI coding assistance world, whatever is true of human developer will also be true of LLM. For example, if this type annotations serve as documentation for human developer, then they will also serve as documentation for our AI coding assistant and for LLM. So on the margins, having properly type annotated functions, return objects, variables, etc. throughout our code would constrain the hallucinations from LLM response. So for instance, if cursor agent already sees that this function has parameter config of type chat config, then it's less likely to give us a response like what we have here, where it will call a function with wrong arguments. So far, even though we have implemented. In fact, cursor has given us type annotations in its response. We have yet not enforced it. And all of these type annotations, they are inbuilt and they come by default in Python standard library. Okay, so let me just show that by creating a dummy function. Okay, so we'll create a function that just takes in a list, prints all its elements out. Okay, we will type it by using list, and it's a list of strings. For item in list, print item. So at this point we have typed our function parameter, which is a list, using this annotation, which is basically using list, hinting that it's made up of strings. Now none of this we have had to import from any external packages. They are all inbuilt within Python itself. So type hints, unless you have to work with some complex data structures, are inbuilt in Python itself. But where we'll have to take some help from external package is in enforcing those hints, because again, currently none of this type annotations are being enforced, and we are not being told if we are making a mistake, as we did here in using the string data type instead of chat config object. Okay, and the tool that we'll be using for enforcing type hints is called Mypy. Okay, it's an external tool, much like pandas, numpy, or any such external Python library that we'll have to use for enforcing type safety. Now there are different ways of using Mypy to do this. For example, we could pip install Mypy, but obviously we are not using pip to install any dependencies, so we won't be using that. We can uv add Mypy and then use it, but even that we won't have to do in this case, because there are instances where we won't be needing packages just for our local projects. We will be needing it all across different projects. And Mypy is one of those instances where it's not just this Python project, but any other Python project that we might work on tomorrow will also be needing type safety implementation. And in cases like those, it doesn't make any sense to keep installing Mypy in different projects. So what we will do in order to enforce type safety in this case is just run this command uvx mypy, and then if we want to enforce it across our project, we'll use dot. But in this case, we want to type check our main.py file, so we'll be running this command. And where uvx is different from running normal uv add command is that it won't be installing Mypy in our local project, but rather it will be installing it in our global cache, and then we can use that as a tool across different projects without installing it in our local virtual environment here. So if we run uvx mypy main.py, so let's look at the output that we got from our uvx mypy command. Okay, for now we will ignore our first two errors, where it's trying to find some kind of implementation for types from OpenAI and .env module that we have implemented. If you look at our imported modules for OpenAI and load.env, it's giving us the error because it can't implement the type safety rules for those two modules, because it's not able to find what we call library stub. Okay, we'll discuss it later, but for now let's just ignore it. Let's look into this two messages. Okay, so what it is telling us is that by default, bodies of untyped functions are not checked. Consider using check untyped defs as an argument while implementing this Mypy check. Okay, so let's do that part. So we will essentially run the same command we did, except this time with this flag that we got in our error output. Okay, and we want to type check main.py, and as you can see, now we are getting that error where essentially Mypy is telling us that argument 2 to get AI response has incompatible type string, whereas it expected a chat config object, which is what we expected. So if you look at that mistake that we made here, is that this second argument should not be a string, it should be a chat config. So it gave us correct error. And if you look at this three errors, they all are because how loosely we have defined our API params dictionary. For instance, if we look at API params here, where we are starting to define it, it has this key value pair where our key is model and our value is string. And then we have a key value pair here where our key is a string and our value is messages, which is essentially a list of dictionaries. And where Mypy is getting confused is that at this point, it is assuming that the next key value pair which will be adding to API params will be of string data type for key and some kind of list like data structure for messages, which is what it means when it says it was expecting a sequence which is made up of a collection. Okay, this is a very broad generic way of data typing something that is a list or a tuple or similar data structure which has a sequence to it or an order to it. Instead, what we have done is at various points. So if you look at this here, we are assigning what will be an integer, okay? Or this point where we are assigning what will be a float. So temperature will be a float and max tokens will be an integer. and that is what we are assigning as a value to API params dictionary when Mypy is expecting a sequence. This is where we'll be taking cursor's help to change this part, because not only are we very loosely passing in API params dictionary by unpacking it within this API call, but we are also failing type checks. Now, if this is your first introduction to type hints in Python, then it might seem overwhelming in terms of different terminologies that we are throwing around already, but it's okay. You don't have to become a super expert and understand everything about type hinting in one day. Just understand that what we are trying to do here is be as explicit as possible about what data types we are using when it comes to different data structures throughout our code. And we'll be taking a lot of help from Cursor to implement this properly while we keep learning more and more about the types along the way. Because I have been working with Python for years and I don't understand everything about types. I still come across things that I have to spend a fair amount of time understanding. We can also run this Mypy command using strict mode, which will also give us similar errors. Let us run uvx mypy, and this time we'll be using -- strict to run it under strict mode, which will implement maximal type safety. Okay, so as you can see, it has given us that same error that we are passing in string when the expectation is that get AI response should have chat config data type for our second argument. Okay, along with it, it has also given us a lot of other errors, much more so than what we got in our previous command, because we are running this under strict mode. Now, Mypy has many configurations like this, which we have to use for type checking production projects, and it's not reasonable for us to supply them over the command line every time we are running Mypy commands. This is where we have to codify all these configurations, and obviously anytime we want to add any configurations, the most logical place for it is pyproject.toml. So let us first construct the prompt for getting these configurations. Okay, we'll go to ChatGPT. We will give AI model the persona of an experienced AI engineer. Okay, so you are an experienced AI engineer working with production grade Python projects using Cursor AI as your AI coding assistant of choice. Write a detailed prompt to get Mypy type checker configurations for Cursor agent. We can also specify that we are looking for pyproject.toml configurations. And as you can see, it's reasoning through different steps here. So as you can see, we have a fairly detailed prompt for Cursor. So we will just go ahead and copy this, and we'll go to our Cursor editor and we'll paste it here. We will select our agent to be Sonnet 4.5. And our expectation is it will read through our repository and modify pyproject.toml file. Now, for whatever reason, Cursor did not make changes to my toml file, even though I'm in agent mode. Most likely there's something in the prompt which is preventing to do it. So let me just ask it to modify toml file directly. This is a weird way to prompt it to modify the file when I'm expecting it to do it, given it's an agent mode. Very confusing behavior. So now let's go through the configuration. Okay, we have this comments, and then our Python version is 3.13. It inferred that from our metadata, then our strict mode settings. So this means that when we run Mypy from command line, it will always be under strict flag without us having to manually give that flag. This all configurations look good. So let us keep all of it and save this. Clear our terminal. And let's try to run that command again, except this time without any flag. This time it's giving us a lot more errors than we got before we added those configurations in toml file. Now let's manually fix some of this errors to understand what type check is all about. So we'll go to this first error, where essentially Mypy is telling us that we don't have a return type for this function. So we have defined our chat config class, and then this is our constructor. Every time we instantiate chat config, it will call this function and initialize all of this attributes that we have here. Okay. What Mypy is complaining that because this function doesn't have any return type, we are supposed to use none as its return type. Okay, we will save this. If we run Mypy again, it won't give us that error. It will still give us the other errors which we have not fixed, but you can see that first error is gone. Now if we go to the second error, in fact Cursor is already giving us a suggestion for that fix. Okay, so what Mypy is telling us, even though we have typed, okay, so our conversation history, which is supposed to be essentially a list of messages, and messages are supposed to be a dictionary, but Mypy is complaining that our dictionary is generic. It doesn't have types defined for it, and in our case the messages were essentially made up of key value pairs, both of which being string, and even more specific than that. One of the keys would be role and another one will be content. But essentially what Mypy is asking us that we have to type our dictionary more precisely than what we have done here. And in this case, we'll go with both key and value of dictionary to be string. Okay, and the moment we do that, Mypy will stop giving this error. And one more change that came into more recent versions of Python is that instead of using this list and dictionary, which we are importing from typing, we can actually get rid of this imports. And instead of using uppercase L, we can use lowercase l, and here we can use lowercase t. And this will work from Python versions 3.10 onwards. Then if you look at the third error here, again, it's Mypy complaining that because this function is not returning anything, we should have its return type annotated as none. And the moment we do that and clear our terminal, run Mypy check, it will not give us those errors. Now, obviously, we don't want to manually fix all of this because the entire point of using cursor is that we can actually offload responsibilities like type safety on it as much as possible. So what we will be doing now is prompting cursor to implement type check using whatever configurations we have defined in pyproject.toml. And we want it to use uvx mypy command. And as you can see, it's reasoning through the configurations we have in our pyproject.toml, and the expectation is that all of the type errors that we currently have in the code should go away. And as you can see, it's running uvx mypy command to ensure that it has fixed all of the type checks. And if it has not, then it's again going back, fixing it before running uvx mypy command again. See, so it's again running uvx mypy command here. My guess is because it has not found any issues in this run, it will soon give us some success message. Okay, so it's now giving us the success summary message of what all type errors it fixed, telling us that your code now passes strict Mypy type checking and is production ready. So let's review the changes. Okay, so it has annotated our return type here. This looks good. Has annotated messages to be a list of dictionaries with string as key value pairs. Looks good. None return type, none return type, none return type. And it has, this is quite loose typing. I don't like it, but we'll modify it sometime later. It has defined our API params to be a dictionary which has key as string, but it has extremely broad data type for its value. It could be anything. That is generally not good practice. We'll review that later. Okay, for now we'll accept it. And it is making sure that if we are not getting anything from our AI, then it should return an empty string. And that conditional, this part where we are converting an undefined AI message into an empty string, is so that this type check doesn't fail on line number 263. If we don't have an empty string here, then our conversation history type check will fail, because our conversation history is typed as a list of dictionary with string as key value pairs. So string as a value cannot be none or undefined. It has to be a string even when we are not getting any response from AI. And that is what this conditional is trying to implement. Okay, so let's keep this. Our main function is not returning anything, and our AI response, yeah, this is one of those artificial errors which we created when we use config as a string. Okay, so that also it has fixed. It's trying to import any from typing module. So looks good, and I think this will certainly pass everything under our Mypy check. Okay, so let's run uvx mypy main.py, and as you can see, there are no issues found in our source file. So this is a good start. Again, I don't like the approach it took when it tried to very broadly type this one. Very rare, like anytime you find yourself using any as your type annotation, just try to double check whether you can narrow it further. Okay, and in this case, I'm pretty sure we can narrow it further, and we'll do it in subsequent videos. Okay, so just to end this video, if you're only starting out with type hinting or type annotation in Python, this might be a little overwhelming, but you don't have to get super advanced with typing on your first go. Okay, in fact, I have been working with Python for a few years, but I still find it extremely tedious and difficult at times, where I have to go back and learn some new things which I had absolutely no idea about. Okay, so just the idea is that to understand enough about why we have to use typing and how to use cursor in order to turbocharge your type hinting. And you keep learning as you go, as you come across different edge cases and scenarios. Okay, so thanks for watching this video.